Hi, welcome to this lesson on calculus sketching cubic functions. Let's have a look at question 6. We're given the sketch of the function f prime of x, so this is the derivative function, with the following information. The first derivative at the point 1 is 0, so that's this point here, 1, 0. And then f at negative 5, the y value is 0 for the derivative function. Okay, so what do these two things tell us? These tell us these stationary points, or turning points if it's a cubic function. Right? Then it tells us that f at negative 5 equals negative 2. So this is on the original function, okay, original f of x, which is probably going to be a cubic function because the function of here of the derivative is quadratic. So this is going to be 1 degree up, so a cubic function. So we know a point on there. At x equals negative 5, the y value is negative 2. And then again, another point on f is 1. Then x is 1, y is 6. So we want to sketch the function f using this given information. So let's go ahead and first put the two coordinates because those are really important. So at f equals 1, okay, so there's the origin, then your y value is 6, which is up here. So that is a coordinate on the function. Another one is at negative 5, the y value is negative 2. So there's negative 5, negative 2, so over here, negative 5, negative 2. Okay, so we've used these two pieces of information. But f prime negative 5 equals 0, this one here tells us that that's a turning point. So the graph is going to turn either like that or like that. Okay, and then f at 1, which we know the coordinate there, it's also a turning point. So it's either going to turn like that or turn like that. Okay, so what other information were we given? Well, look at this graph. Okay, this tells us that between negative 5 and 1, the graph, the derivative is positive. So we're saying that f prime x is greater than 0 here. So this means the graph is increasing on that interval. Okay, similarly here, in all these regions, the y value is negative for the derivative. So the f prime x is less than 0 if and only if x is in between negative infinity to negative 5, union from 1 to infinity. So that's the graph decreasing. Okay, so let's look at the increasing interval first because it's quite short. Okay, so from negative 5 to positive 1, we said the graph is increasing. So I reckon that it's probably going to turn like this here. Okay, so it increases up to this point here. And then we saw from negative 5, or negative infinity to negative 5, the graph was decreasing. And it was decreasing again from 1. Okay, so I think we got a pretty good solid shape to go on here. So I'm going to draw it like this. So it's going to decrease, turn at negative 5 as a turning point, increases again to the turning point 1,6, and then decreases again. Okay, and that would be a good rough sketch of this cubic graph of f. Let's see that it matches all the properties again. So we see here, so let's just move that points there. Okay, so f prime at 1 is 0. Okay, there's the tangent line at at x equals 1. It's a turning point. At negative 5 is also a turning point, so the gradient of the tangent line is 0. F at negative 5 is negative 2, which is what we got here. And then f at 1 is 6, is what we have here. And then based on the graph, on the intervals of increasing and decreasing, it increases from negative 5 to 1. So from negative 5 to positive 1, can you see your graph is increasing? And then from negative infinity to negative 5, your graph is decreasing. And then from 1 to infinity, it's decreasing again. Okay, so this graph here matches all the given properties of the information that was listed for us. Awesome. I'll see you in the next one.